Oh, if we are ready.
It's not 2020 yet, so
Thank you, great.
20th, 11, 20.
your guess is as good as mine.
I still have no idea where to find our materials. Where?
I was not sure. I was looking up Google. Just, IETF meeting material about research.
Okay. Shall I do that? I'm going to go
Right here. Sign your sheet.
materials.
Yes.
Friday morning.
It's all his fault. Right? To make it a little bit clear.
Autonomic.
Maybe he doesn't have.
Thanks. Integrated something. Anima.
Autonomous
network.
He knows.
Integrate management.
What's his prime contribution at that point?
And approach. I found the last approach. Okay. So.
Come on, folks, you want the random new experience.
Yes. What was that called? Chat roulette? Or chat roulette?
Okay. Everybody, it's time to start. We are 2 minutes late already. So this is the ANIMA session, autonomic networking integrated model and approach. Am I right, Michael? So
Approach, is that what it is?
Yeah, approach. Whatever the name, we have that for 5 years. Okay, this is not well. You should have that not well, the same not well for 5 years already. So you should really read it. And I assume you did. Before began the meeting, we have distributed the blue sheets around. Make sure you're signed before you leave, no matter how early you are. And we need job scraper. Normally, Terry's could do that. Yeah, and we need really a minutes taker volunteer for that. We have problem last time. We cannot do the meeting without a minutes taker. Brian? Okay, thanks, Michael. And we also have the remote participation and all the slides. We got 5, I believe, already uploaded. Main list is the official working place. All the designs, rough consensus we made in the meeting room will have to confirm on the mailing list. And the chair is myself, Xing, and Terrace. Okay, that's the agenda for yesterday. This is agenda for today. We have the working group document update. Brisky first. And we should have the constraint voucher update as well, but we don't have slides, and there's no update. But that could mean we slow down the process to reach the working group consensus, right? Okay. Okay, that's fine. So whatever you want to take your time. Then we have Brisky Cloud Registrator. That's by Owen. And the Brisky AE updates by Stephen, and the ACME integrating with Brisky, again by Owen. Then the last one without a draft is the proposed delegated voucher by Michael again. Okay, that's the agenda. Any agenda push? Once, twice?
Well, if Ben shows up, the ACP argument discussion. Yep. Yeah, we mentioned on Tuesday that if the security AD has time to come in, then would basically give it some minutes to discuss the what he considers to be one of the open points on the ACP review.
Yes, but by looking at this agenda, I think we have some possibility to finish earlier. Yeah. So it's not matter whether he has some time. It's a matter whether he catch us before we end it. Yeah. Okay. So first one. Key update.
Oh, it works. Today?
Yeah.
Hi.
You
have to put it in the order. Yeah.
Full-screen model before we actually push that button.
That's right. Yeah. And then somehow if you did it in the wrong order, you have to start all over again by rebooting the computer and leaving the room and coming back. Okay, hi. So update on bootstrapping key infrastructure. It's been my life for 3 days a week since the last IETF, it seems. And this is what I told you last time, the various edits and comments and discusses that we received. This was last time. So this is since then. Let me see, there's a button that lets me do the light. Yes, which remote people can't see, of course. So these ones are, I got ADs to say something like okay and remove their discusses. New revisions were posted. There's some periods in August with intense discussions, mostly with Ben Kaduk, on the security parts of it. Alyssa gave us her okay and then removed it again, pointing out there was a Yang Doctor review that we hadn't addressed. They were mostly editorial nits on the Yang document that I fixed. I'm waiting on okays from Roman, Ben, and Alyssa. This were periods of pestering of ADs where I emailed Unicast them multiple times, not more than once a day. But you kind of have to do that and get them to pay attention. And you have to know when their telechats are so you don't bother them when they're reading other people's documents. Okay, so what happened? Since the last IETF, the abstract got revised. Part of this, the challenge is, I think, in abstracts is how to write it without using the acronyms that you haven't expanded yet, and you can't expand them in the abstract. So that's always a challenge. There was a mixing XML registry that was added. And section 9.1 included operational requirements for the autonomic control plane applicability. So this is a mass operational requirements, a domain owner operational requirements, device operational requirements. A section was added called death of a manufacturer, which what happens to the devices if the manufacturer goes away. Willie Loman is a character from Death of a Salesman, if you don't know that. there's a diff at the top of the thing if you have the slides downloaded and want to load that, and you can see the diff. 11.6 expanded to include another situation for the manufacturer where if the manufacturer messes up and loses his MASA or CA signing keys in a fire, whatever, they didn't do it right. We sorted the terminology alphabetically. I guess we had been adding the terminology in a kind of grouping with related terms that seemed related together. So at some point that made sense to us, and clearly it didn't make any sense anymore. Just sorting it made sense. After that, there were many TLAs that weren't expanded before they were used. We fixed that. Added a reference for RESTful APIs. That actually was a bit difficult to find an appropriate reference that worked out. Left the reference for 802.1ar at the 2009 version, despite several people telling us how wonderful the 2018 version is. I can't download it. Several of the people who've spoken to have been unable to download it. We have multiple tickets open with the IEEE webmaster, who basically clearly thinks we're idiots and has asked us to do things like reinstall our browser and stuff like that, because that's obviously the reason why we're getting XML errors from his single sign-on system, is for that reason. So don't ask me what I think of the IEEE, because I don't think I'm allowed to. The code of conduct would prevent me from telling you that. Figures were, I think, already renumbered, but some descriptions were missing. We had some comments about the fact that the IDEV IDs, some systems were unable to produce proper IDEV IDs, which are supposed to have an expires on, and you're supposed to put in the maximum number, which is 2999 or something like that, 1231. That's supposed to be the date that's infinitely in the future. Some of them are unable to do that, and we had some comments. We had some weasel words around that, and I guess the conclusion is that in the number of years since the document started, those CAs have been fixed. MUD got published. We fixed those links. There was quite a bit of I think, lack of understanding among some reviewers that the ACP has IPv6 link local addresses for enrollment, and you can't reach them from outside that link, and that's why the link is secure, because you can't talk to link local addresses unless you're on that link. Had a bunch of goofs in some of the voucher examples. One of our original authors who came up with some of the concepts is a guy named Stenthor. I've actually never met him, but he's known by other people, and after some consultation among the authors and the area directors, we removed him as an author, and we added editorialists who actually did a fair bit of work on editorial things over quite a few years on this document there. And then people complained that the Yang Doctor list was not the author list was not the same as the document. We fixed that. We had a CDDL definitions for pretty much everything at this point. So we fixed it for I guess, when we started this document, GRASP was just hesitantly using CDDL to describe itself. CDDL is now published and they're doing BIS. So it makes sense to do that. We added CDDL definitions for all of the JSON-based stuff. So like the audit log, the telemetry status, the enrollment log, and there was a lot of back and forth about RFC 6125, which basically says when you get a TLS certificate, how do you know it's the right one? And we're just saying, well, you do what browsers do, and apparently that was not acceptable to say. So we had to add some other text there. There was a lot of push about why can't we just make it TLS 1.3? And the answer is that from quite a number of implementers that we received feedback from over a couple of years, including, by the way, me, right? There's no TLS implementation out there that does 1.3 and is FIPS 140 compliant. So if you have the constraint that you can only ship FIPS 140, crypto on your device, then you are limited to implementations right now that don't support your older implementations. Okay, and you may know, if you're familiar, OpenSSL, for instance, their FIPS compliant stuff was supposed to be available for their 3.0, which will have TLS 1.3. That's supposed to have been available next summer, probably won't happen till the end of next year. So even though, yes, their current code base is totally TLS 1.3, you're great. Wolf SSL, it's, you know, they're 1.3, and that's great, and they have a FIPS library as well, but that's not drop-in compatible necessarily to, you know, certain platforms. So what we've said is that TLS 1.2 suffices, but we would really like everyone to support. We would like them to do 1.3 whenever they can, and but 1.2 support is necessary on the various endpoints. There's some other points about the clarifications about manufacturers and list of manufacturers and things like that. We did a lot of work to try to get rid of the domain ID, which shows up in the audit log, which is essentially the abstracted hash of the owner of the registrar. We had said it's the SHA-1 hash of the public key, or actually the subject public key info structure. And that comes from RFC 5280 and a couple other documents that specify SHA-1, okay, or some other way of calculating it, which they don't specify. So the question is, they don't want us to say anything about SHA-1, and that's okay. But the issue is, well, if the registrar's certificate doesn't have the subject public key info, subject public key, there's a OID extension that you would normally put the fingerprint in. I can't remember the name of it right now. But if the CA has calculated it already using whatever algorithm it likes to do, then it puts in a 16 or 20 byte fingerprint, and that's the thing you use to reference to that key. So if they've calculated that, then we're good. You just use it. That's the point. If they haven't calculated it, then we all need to agree on how to calculate it. So that's why you wind up with the SHA-1 reference, because that's what current things are. So we found a reference in another document. I will have to look at the document to tell you which one, where they essentially went through the same problem. And the answer is, well, you use SHA-1 if you haven't figured it out, but please calculate it when you get a CA key, because then you won't have that there. And as I said, I'm really hoping to run after some more area directors this week and get them to sign off on the thing. And I just mentioned, I've started 2 documents on operational considerations for Brewski registrars and Brewski Massa, and they expand considerably on some sections that we were asked to put into this document. And I had avoided putting that kind of information into the document because I think it could be easily a, 1 to 5 year fishing trip of interesting things to say, and I didn't want to open that can of worms. So I hope that the document is sufficiently complete about, yes, there are considerations that you need to think about, but that I'm not trying to write a cookbook on how to run things, but I am looking for help on that. And I'm going to go on and talk about constrained voucher for 1 minute. Okay. Yeah. Okay. Yeah. I could take questions if perhaps at this point.
Yeah,
instead.
let's interrupt between the different documents so people can start breathing. Yeah, questions, please.
Ryan Carpenter, I don't have a question. I would like to propose a vote of thanks to Mr. Richardson, because he's done an enormous amount of work on this.
Thank you.
Just one question on the implementations. I've seen your implementation and I reference Massa Register. Are there others that are? Yes.
So I could have put a slide in that because I even had one made for something else. That's Shwesta. Yes, we in fact have had done interoperability testing, we being the I guess I'll say the Fair Hair Alliance, which is now part of the OCF, between Siemens Building Technology, NXP, Sci Labs, myself, and Signify was initially a participant, but they didn't. I think they ran out of patience, I would say at some point. And we have mixed amounts of success between the implementations. Mine's the only one that's publicly available, but we have some things have interoperated well, and some things have not. At the last IETF, you saw one of the documents was the clarifications of RFC 7030 about whether or not things are base 64 encoded, and that's some of the stuff that came out of that, because 7030 basically says you base 64 encode things. And then mark it in a way that HTTP says is forbidden. And then that also confused people into believing that you should base 64 encode all the Brewski vouchers and responses, which there's no reason to. So we went into this thing, and to make things more complicated, of course, many of the times for debugging of our stuff, the debug info that we get out of our programs is base 64 encoded. So we're not actually sure if we're like, oh, am I looking at the wire and seeing base 64, or did I just base 64 that encode it so that I could debug the thing, right? So there's a couple times when we had interoperability because we all agreed to base 64 things when we actually weren't supposed to, right?
Thank you, Rich. Michael, but how about the real deployments where it's actually being used?
So Thread is adopted it for their application server enrollment. Some of the participants that I mentioned, there's one university that has a research lab, have done this sort of top to bottom with Thread. There's no production deployments of it anywhere. There's demos at meetings and things like that, but there's no production deployment at this point.
Thank you.
Anybody else? So constrained voucher hasn't changed since 105. Constrained voucher was stalled by a couple of things. The major thing was the progression of the Sid Yang documents in the core working group. Those were unstuck a little bit at 105, and then have not progressed again, as far as I can tell. So we did get our SID allocation done on like the last day. So we have to change our SID number. So these are the indexes into the map of the CBOR that tells you, maps the big long strings that we have in the JSON, or they're not big long, but there's strings in the JSON to small integers. So they've given us a new mapping base. And that requires that, at least for the examples, that we go back and fix our code and do interoperability testing again with it. And there simply hasn't been time to do that. In addition, Peter Vanderstock, who's not here this week, is looking for work. So he hasn't had any time to work on the documents either. So there's been no progress on that. But even if all of the things that were in our way were not in our way, I don't think any of the authors would have had time to progress the document, since we have other documents. COAP EST is in the IESG discuss, so that's a dependency of the constrained voucher document, and so there's a couple other documents that would limit our progress anyway. So there seems no point in running fast and stumbling for that document. Any other questions about that? Come to the core working group and tell them to get SID out of the way. Read the SID document if you want this one to progress.
Yeah, yes and no. I still have problem for the slow progress on this draft.
Okay.
Yeah, because giving you also propose some other new work.
Sure. I hear what you're saying is how dare I do new work when I haven't finished my old work? Yeah. So I take your point. You're absolutely right. My feeling is I have to fix my code before I can produce examples. And that is unfortunately a different mindset for me than writing documents or editing documents. But I haven't fixed the code, and the other documents suck too. You notice that? The other ones are pretty bad. So not exactly you doing a lot of work anyway. Okay. It's at least one other document has another author, which is the 6-tish version of the constrained voucher, has a new author who has a lot of enthusiasm and energy. And so hopefully we'll make some progress on that as well.
Yeah, I fully respect your work and your logic, and thanks for your contribution to a working group. But as a working group chair, what I can do, for my job is I'm not willing to adopt your newly proposed work until you tell me you have enough energy to do so.
Sure, that's totally reasonable, and I totally respect that, and I think that's a really good policy for the group. I agree with you completely. Okay.
So
we're done here.
We don't have issues. Okay. Thank you. Next will be Owen.
Is this about the slides you sent emails with us that they're missing? Is it? Okay. No, if you just emailed them now, then I'll need 5 minutes.
So, another version?
No, let's do the Acme stuff first, and then I'll upload the cloud and.
While it's figuring this out, what this is, it's this deck was presented, or a variation of this deck was presented at EMU and was presented at IETF105 as well. What it is it shows how Acme can be used for to enable multiple different. How Acme can be used to integrate multiple different integrations for facilitating client or device search enrollment. And the one that's interesting here is search enrollment with EST or Brewski. No, doesn't work. Okay, well, yeah. So base Acme, it can be integrated with multiple different existing client and device enrollment mechanisms. The one that's of interest here is Brewski or EST. Next slide. So what the Acme integrations draft does cover is it covers how Acme can be integrated with EST, Brewski, the new Brewski Cloud Register draft, TEEP, and there's a new draft for TEEP update. The one that we'll touch on here is EST because Brewski is based on top of that for the enrollment piece anyways. Next slide. So we presented this last time around. So what's changed is an Acme subdomains part has been broken out as requested at the Acme working group. What Acme for subdomains does, it's a nice optimization. It enables a Acme client to prove ownership of a parent domain and then issue search enrollment requests for hundreds or thousands of clients off that parent domain. And also we've added the Brewski Cloud use case has been added to Acme integrations. Next. So yeah, the two main protocols that we can integrate Acme with is EST and TEEP. So both EST and TEEP describe the protocol for how the client or the device interacts with the EAP server, the TEEP server, but both protocols, it's out of scope how the server interacts with the backend CA, so we can plug in Acme into that. Next. Okay, so this is a bit of an eyeful, but it's straight out of the specs. So on the left-hand side is just boilerplate Acme. It shows how an Acme client can interact with an Acme server and prove ownership of a parent domain. I'm just showing the example of domain.com here, and it does it via, well, there's multiple mechanisms by which you can do it, but the mechanism I'm showing here is simply by publishing a text record to DNS and proving ownership of the DNS domain. And on the right-hand side, what I'm showing, and this is actually, the picture on the right-hand side is from the previous version of the Acme draft, and it's missing something. What it's showing is how a pledge or a client, when it's interacting with an ESD RA or a Brewski registrar, how that client can send ESD simple enroll request to the RA. And what it should be doing first is sending a CSR attributes request. The CSR attributes request is documented in the latest version of draft. It's just not shown in the slide. It sends a CSR attributes request, gets a response, then sends an ESD simple enroll request to the RA. It's the same enroll request that's sent for Brewski as well as baseline EST. The RA can then turn around and interact with Acme and send a new order request, send a finalized request, and send a certificate request. If necessary, can reply with a 202 if it's going to take a long time for the cert to be issued, with a longer time interval. Once Acme has issued a certificate, then the RA just turns around and replies to the simple enroll request with a PKCS7 response. And that's pretty much it, right? So on the left-hand side, we have standard EST or standard Brewski. On the right-hand side, we have standard Acme. There's no changes required to either protocol to get this to work. The one optimization that has been proposed and has been discussed at the working group on Acme on Friday is Acme for subdomains, which is a really useful optimization for issuing device-side certs. But apart from that, there's no reason why we can't plug these two protocols together. There's no reason why we can't plug Acme into TEEP as well. Next slide. So what's missing from this is security considerations. But I think the big open question is, like, this integration spans across the Acme, the EMU, and the ANIMA working groups. So where does this doc live? And quite a few people have expressed interest in it. There's interest in EMU, there's interest in Acme, there's been interest here as well. Where does the doc belong, and how do we bring it forward?
Has the document been presented in these other working groups?
In EMU, yes.
In EMU. And so what did the work?
So in EMU, in order for this to work cleanly with EMU, we actually do need a couple of updates to TEEP. So EMU working group are supportive of it, but want the TEEP updates to happen first before we can cleanly integrate TEEP with Acme. And EMU are considering, well, once the TEEP work is done, it may make sense for this Acme integrations draft to live in EMU. We don't know. And we're going to have the same conversation on Friday at the Acme working group. Right.
Okay, I'll try to be there. So
okay.
Frank Xia, Huawei. Is this about the Acme integration?
Yes.
Okay. I have a question. If you, I want to know the exact use case of this Acme application. You mean the CA is some public CA, so
yes.
You need to use Acme too. Okay.
Well, Acme is just a protocol. It may be a public CA.
Yeah.
Like, there's no reason why a private enterprise CA couldn't support Acme as well.
So I just want to ask this: if it's a private CA, so is Acme this kind of Acme extension still applicable, or actually we don't need this kind of Acme extension?
Well, it really depends on what what interfaces the private CA supports. Like for example, well, what we see typically, most of our customers run Microsoft's private CA. That's what we see. And to integrate with Microsoft CA, you have to integrate with their custom proprietary APIs, and which means if you actually want to build an integration to Microsoft CA, you need to get an SDK and build a custom integration onto your RA to integrate with Microsoft CA. Now, there are some CAs that do support Acme that you can deploy on-premise, not Let's Encrypt in the cloud. You can deploy Acme on-premise, and what this does is if it's a private CA you can deploy on-prem that supports Acme, this is just a standard way of integrating that with any RA.
Okay, thank you.
Okay.
So have you, are you interested to ask for adoption in the different working groups? Is that your current status? You think it's ready for adoption, whichever working group, but you think in terms
well,
of
I don't think it's ready for adoption yet. But we need to find out where it lives first, so we can get the right people to do a proper review and suggest changes before we can adopt it. So
well, I think the fear is, given how it kind of spans across those, you want to have reviews from the different working groups anyhow. So wherever it's being adopted, it's probably good to always keep at least two of the working groups updated on it.
Absolutely, yeah. So I'm looking for some advice on what's the best way to tackle this. I mean, do we go back to SecDispatch and ask SecDispatch what to do with it?
Well, so as far as us is concerned, remind us after this event in terms of, that as working group chairs, you should...
maybe it's as simple as send an email to the working group chairs for Acme, Anima, and EU and say, guys, what should we do?
Yeah, so that we at least kind of just administratively figure out what opinions we have about it.
So we'll have exactly the same discussion on Friday at Acme, because I'll be presenting Acme subdomains on Friday, and just briefly mentioning this. Then after that, maybe it's just bring it to the three chairs matters and see.
Michael Richardson, I think it probably belongs in Acme. I think that if there's I think that the only issue I think is going to be working group milestones and load, and in which case asking SecDispatch might be the useful thing, but I don't think it makes a lot of sense. I think you wind up in Acme. I think that's the right answer.
Yeah.
Can you say why?
Because I think that there are no protocol different changes to Brewski that it impacts. You said there are some TEEP changes that are required, but as I understand them, it's because of validating of it's the whole conversation about the ETLS certificate and that thread that's happening right now, right?
And it's to do with retry mechanisms.
And retry mechanism.
Primary changes are retry mechanisms,
so retry mechanism,
and CSR attributes.
Yeah. So that will have an impact. So the document needs to be kept track of there. But I'm saying it's primarily. I think primarily it needs Acme review rather than other entities review. That's why I'm saying I think it belongs there.
Probably does.
Right. So I don't think we'll get a working group last call review from Acme people if it was an EMU, for instance.
Yeah.
Right.
Yeah, but anyways, the purpose here is just to make this group aware that this work's ongoing. Okay.
Was the cloud document? So you need to refresh. Then the title should change to Cloud Registrar V1. Yeah. So that was V0 first. So that you start always numbering, but we're kidding. Please come back. But these are the slides you sent me. Yes.
Yeah, it's the right slide too. Okay, so what this document does is it describes in more detail the operation of a default Brewski Cloud registrar, which is touched on in the base Brewski draft, but is not really explained in any detail at all. The next slide. Yeah, so the Brewski draft doesn't fully specify default cloud registrar operations. This draft does. Well, really what it captures is most of the options that are available, and there's a bunch of open items we need to work through. The two primary use cases for a cloud registrar are a pledge bootstrapping from a location remote from the domain where it wants to register. It has no joint proxy and needs to discover the location of its home registrar. And the second use case is a pledge bootstrapping in a location where there is not yet a registrar, and it may need manufacturing assistance in bootstrapping. So one is, you're booting in a remote location, and two is you're booting in a legacy network that doesn't have a modern RA deployed.
What's the difference between a default cloud registrar and a non-default cloud?
Well, a default cloud registrar is when the pledge bootstraps, it tries to discover a registrar on its local domain or the domain it's bootstrapping in and cannot find one, and there is a default manufacturing registrar baked into its firmware. Like say it's a Cisco device and it has registrar.cisco.com baked into it, and it just goes to the manufacturer's cloud to find out where do I go next.
So it's kind of a fallback?
It's a fallback one, yeah. And it's documented in the Brewski draft, this operation, but it just says if a pledge cannot discover its local registrar, it can fall back to the cloud, but it doesn't really say what happens after that.
I think fallback, and I wouldn't have asked the question.
Okay. Next slide. This is the high-level architecture showing all the moving parts. There's multiple different possible signaling permutations and combinations that need to be worked through. But the pledge is going to connect to a cloud registrar on Bootstrap and request a voucher. The cloud registrar will enforce mutual TLS. The cloud registrar will check to the device's IDEV ID. And the device is going to use a baked-in implicit trust anchor database to check the manufacturer's cloud registrar identity. And there's multiple different choices about what can happen next. Like, does the cloud registrar issue a voucher directly, or does the cloud registrar 3xx redirect to the correct local domain or home network registrar? If the cloud registrar issues a voucher directly, where does certain enrollment take place? Does certain enrollment take place in the cloud, or does the cloud registrar redirect to the home domain to do certain enrollment there? And if certain enrollment happens in the cloud, and this is a use case that a buyer is very interested in, how does the cloud redirect the endpoint to its service domain? And that's not specified at all in Brewski, because Brewski is all about attaching to the network, not attaching to services. Next slide.
Just a quick question.
Yeah.
How do I understand the home domain? It just mean the local domain or home
Well,
network?
let's say one example is you plug in a device in your home network, and
that's
you're
what I remember.
a remote worker, and you want the device to register to your headquarters.
Okay. I mean, does it also? Is it a more general concept, or it's specifically on the home network?
No. Sorry, I can plug it in. Yes, I want to discover my headquarters, or home is kind of an overloaded term. Maybe it's confusing.
So
it doesn't
it's a
mean
local domain something, right?
Well, so your local domain is where you power the thing up, right? You've powered it up here in the IETF, but the device, you want to actually register to my Cisco office in Ireland, right? Or
Home domain.
so I unplug the box. I'm a remote worker. I power it up on my home network. I'm a remote worker. It connects to the cloud, and the cloud will redirect it to the corporate network or the operator network that I want to connect to. Next slide. So for home domain, or the domain that I want to connect to, not the domain I'm booting up in, home domain requires mutual authentication, so the pledge must be imprinted with a trust anchor for the home registrar. The pledge may need to be imprinted with a realm or domain information if the home registrar is using an identity cert that's signed by a public CA. So that's currently not specified how this could work in vouchers or Brewski today. The home registrar must either have visibility to and verify the vouchers this is issued by a master that's bound to the pledge, or else the home registrar has to verify the locally significant certificate that is imprinted on the device. One of those two options.
Arthur Hecker, just one short question. Is it possible to have several homes for one physical device? Would it be supported? Because, you know, we have this buyout situations and more virtual domains, like within one physical device, some kind of secure environments, you know, which essentially make it being two devices.
So that's like a general Brusky question though, right?
Right, correct. It's a general question whether it would be supported at all, because I think today we face the situation typically, right? The examples that you just have given, that you connect to your, let's say, enterprise is very clear, as long as we are, let's say, in 2005. But somehow today, I feel that my PC can connect to several homes. It depends on what role it just plays.
So
I have the secure enclaves, right? Which
Yeah.
are even supported from the chipsets. So yeah, correct. So is it supported? Would it work? That's all my question. So as long as it works, as long as the answer is it works, it's fine for me. There's nothing there. Use whatever. Maybe there's whatever. Maybe the same MAC address would then somehow make it not work. I don't know. I'm just asking a question.
Yeah.
Then that's good. I think that's.
Yeah, like this isn't really changing the behavior of Brusky at all, right? Yeah. Okay, next slide. So there's three major deployment and operational models we want to talk through, three major options, and which options make sense. Should we support all of them? Should we support none of them? Are the questions we need to answer. So the first option is when the pledge connects to the fallback or default cloud registrar, and the cloud registrar will do mutual authentication. It will verify the IDEV ID that's installed on the pledge, and the cloud registrar will have a lookup table that says this IDEV ID, this device, should be redirected to this home registrar. The cloud isn't going to issue a voucher response. The cloud is going to do a HTTP 3xx response and redirect the voucher to the home registrar. The pledge is then going to do standard Brusky flow against the home registrar and send a new voucher request via the home registrar. Okay, this is kind of the simplest case. Next slide. So this is scenario number 2, where the cloud registrar is going to issue a voucher, and the home CA is going to issue, or the home CA is going to issue a local device ID. The home CA is going to issue this locally significant cert. So the cloud registrar issues a voucher. The next step that the pledge is going to do is the pledge is going to start the EST enrollment operation. It's going to send the CSR attributes and then send an enroll request. So when it sends its first EST operation to the cloud registrar can 3xx redirect it to the home registrar. Another option, of course, is that the voucher could include the home domain network as a field. That's not in there yet either. The problem we have here is the voucher issued by the cloud is not going to be seen by the home registrar if the cloud just does a simple 3xx redirect on the EST request. How does the home registrar do mutual authentication? How does the home registrar get visibility to the voucher that was issued? Because the voucher that is issued is going to bind the pledge to the home domain, and the voucher that is issued will also have the pledge's serial number in it. So there's a couple of different options for how the home registrar could get the voucher. It could be potentially included as a bearer token in the HTTP request, and the home registrar could potentially fetch the voucher from the cloud, or the lowest common denominator is that the pledge identity needs to be explicitly provisioned on the home network as well as in the cloud. There's three options there, and we don't know which is the correct one to take. Next slide. So in this scenario, the cloud registrar is issuing the voucher, and the cloud CA also issues the locally significant cert. So there's two problems here, right? First, how does the cloud registrar tell the pledge what its home service domain is? Telling pledges about their home service domain is currently not in scope at all for Brusky vouchers. And the second problem is the certificate that's issued by the cloud CA, because the registrar and the cloud CA will be redirecting pledges across multiple different home domains, assuming there's multiple different customers that are leveraging this. How is that locally significant cert suitably namespaced so that the home service domain can do a proper RBAC and policy check? Like for example, if the cloud CA is let's encrypt, it's not a strong enough policy decision for the Home Service just to check that the certificate is from Let's Encrypt. It needs to check out the certificate is from Let's Encrypt, but it's also subdomain.operator.com. That's another open question we do not know the answer to. Next slide. And this is the last slide. It just summarizes the 3 different mechanisms by which a fallback or default cloud registrar could redirect a pledge to its correct home registrar. There's open questions associated with all 3 options. And the questions we have is how many options should be supported? For the options we do support, how do we answer the questions that are posed for each one of those options, and what do we do next? Well, there's 3 options on the table. Which, if any of those 3 options, should we support? Like one of the, the option to support none of them means that we need to upgrade Brusky to remove the default cloud registrar. So we should be supporting one of them, at least. For each one of the options, there's a number of open questions that need to be answered for each option. So we need to figure out how we get the answers for those questions as well. And then what are our next steps? Okay. Yeah. So which options do we support? If we support none of them, then we need to go back and revisit the Brusky draft. So we have to support at least one of them. Then for the subset of options we support, there's open items against each option. And then we need to investigate what the correct answer is for those open items.
So this seems to all be trying to, no, this is too small for me to read. So these options seem to indicate that this is kind of collocated with the MASA, right? At least in one case, and in the other cases it's not. So does that do those other cases introduce?
So the cloud CA does not necessarily need to be collocated with the MASA. Like for example, the cloud could be using Let's Encrypt as the default CA.
That's true, but the question is always that you basically got the IDEF ID as the identifier by which you're looking up in a database to determine.
Yes.
So which is kind of something that the MASA needs to know already, right?
Yeah.
So basically,
absolutely,
you're
so
duplicating information to the same type of information into multiple systems if you're not kind of considering this as an additional function co-located effectively with the MASA.
Yeah, so the MASA and our cloud registrar will have to be pre-provisioned with the LDEV ID or the LDEV ID serial number so that it can look
IDEF
up.
ID.
Yeah, the IDEV ID, yes. Yeah. Sorry, it'll have to be pre-provisioned with the IDEV ID or IDEV ID thumbprint or serial number so that it can redirect.
Right, so if I consider them to be co-located, that kind of sounds the most simple to me, which then begs the question for case 2 and 3, where that seems not to be the case, what the benefits would be over case 1, right? If I correctly identify.
I don't think you're missing the differences. So, Michael Richardson, so so maybe we illustrated this poorly by putting the dotted line around the MASA and the other thing. I'm sorry, it was my suggestion to put the 3 together like that so that you could easily see the differences, but between the 2, that they are different without flipping the slides. But Torlis, the cloud registrar could be operated by anybody. So an example would be XYZ Widgets makes a thing, sells it on Amazon, but the cloud registrar that it uses is Azure's IoT, thing, right? So in that case, there's really a fairly far relationship between the different pieces, and there's no requirement that the manufacturer run the cloud registrar. There's probably some efficiencies. There's probably some you can just dip into the same sales database if you want to and stuff like that. But I don't think there's any strong requirements architecturally into doing that. Okay?
But I need to now, if they're not kind of coming from the same source, I need to trust 2 entities, right? The manufacturer with the MASA and the same type of kind of information with that other party. What's the value?
Well, you need to validate. You need to validate the MASA's vouchers, regardless. That's Brusky. Okay. when you go in the case of two or three, but particularly two, if I can't read it either, then there's still a voucher that's being issued that pins the registrar. Okay, so you don't have to. The device doesn't have to actually trust the cloud registrar, because it's still going to get pinned by the MASA, by the voucher. Same as in Brewski, no difference there. And in at least one of these cases, it is a local registrar. It's just not local to the network you're on. So that's the case where you take a company phone, you bring it to IETF or something like that, and you want it to work with your company, even though you're not actually at the company, and that's why you don't have any ANIMA infrastructure to help you get onboarded, right? So that's where the manufacturer's cloud registrar redirects you to the local registrar, the company registrar, possibly over the internet, but you're still onboarding with that domain-specific registrar.
Yeah.
Right. You could even get your LDEV ID and then bring up an ACP over the internet if you wanted to, right? And that's entirely reasonable. Okay, it could be completely ACP uses as well.
I think maybe the correct step to help differentiating these is to come up with a list of possible attack vectors and how each of them do or do not defend against those.
Sure. So in the phone case, because two of the authors, at least I'm going to speak, Owen, that you also sell phones, right? You're in that phone group, right? Certainly, Rifat, certainly at Avaya it does. In this case, there's no local. It's a hosted PBX solution. So they want, but each customer has, gets a stack of virtual PBX equipment in a nearby cloud, nearby public cloud. And so the manufacturer actually redirects them, maybe only 3 hops down the street to their PBX system, right? And they're going to get onboarded to that system. It just happens not to be within their building. That's all.
One deployment scenario that IP phones need to figure out when you plug it in. So I take an IP phone out of its box in my home office and I plug it in for the first time. I could be getting service from, I'll say Cisco. I could be getting service from a Cisco hosted, it's a Cisco phone. I could be getting service from a Cisco hosted virtual PBX. I could be getting service from a service provider. It could be an open service provider, or I could be getting service from my enterprise's private PBX that they've deployed in my HQ.
Or in their HQ's cloud.
Or my HQ's cloud,
right.
Yeah.
No, I think all these examples are fine. The next step in terms of what happens in the presence of a bad player, what are kind of, how well do each of these solutions protect?
So one of the things between these solutions is where the redirect occurs. Okay, the redirect can occur before you get a voucher, after you get a voucher, or when you ask to enroll. Did I get that right?
Yeah,
I think so.
Or after, and actually, what Rifat really likes option 3. He says that's the use case they need to build.
Yeah,
and I lean towards option 1. So
yeah, so what we don't have is clearly articulated distinction between the 3 use cases. We're just pretty sure that we probably don't need all 3. We're just not entirely sure which 2 to keep and why.
I think one of the answers will be whether the local operator wants to run a CA or not.
Yeah, let's do a time check here, because otherwise this is too interesting. But
sure.
To another. Yeah.
So that's what I.
Thank you.
Yep. Where's the full screen?
Okay, so I know we're a little bit behind schedule, so I'll try to be pretty quick. I am here to try and get this discussed resolved on the ACP document. The RC822 name aspect is probably the trickiest part. There's a few other things that should be pretty mechanical. So summary here is I'm frequently confused. If I'm confused, getting me unconfused is going to be a success outcome here. So please don't be shy about jumping up to the mic. So just set the stage. I'm going to be using the ABNF, except a minor tweak to make it a little bit more sense. I'm just going to go through the ABNF and talk about it a little bit more. So breaking it down to the little components, we've got this RFC self literal string that's just sort of saying this is the type of thing that we're using in our name. And that's sort of my understanding of it. And then we've got the IP address, pretty straightforward. And then in the rsub, so we've got this routing subdomain concept, and we have the rsub string that we prepend to the domain in order to get the routing subdomain itself. And so this rsub is like a prefix. I tried to go back through the email discussion and through the document, and the only thing I could find that we actually use this for is as input to the hash. And so I'm forced to assume that this is also used in like the human readable output that we can get out and extract in the certificate. So it's like used for organizational reporting about which part of the network is this device part of.
No, so basically the whole idea was that the local part should have kind of all the local attributes that we need in addition to, let's say, the simple address stuff. And one of the things we're doing algorithmically out of it is the calculation of the hash. So if we start saying we have the one security domain, which is coming from the ACP domain name, right? So that's basically, for example, where we base the trust anchors, but we're starting with multiple separate networks. Then these separate networks should have separate address prefixes. So basically the rsub creates the ability to have different address prefixes, and so then these can be easier concatenated together, right? So you're basically saying, okay, I've got just one trust domain, but I need to have 5 different networks. If they all have the same addressing prefix, then we can't basically easily partition and put them together.
Right.
If we give, so that it's just, you know, some trick to make the routing
so
easier when we
is
partition things.
for the address assignment, so that we can have our separate partitions. Okay.
Think of it as some large campus, say, I don't know, Cambridge University that you might know, that has sub-campuses in other cities, but wishes to, but doesn't want to run a ULA across all of them. Okay. However, anticipates the possibility of multi-terabit networking, which would change their view on that. And so they want to make sure that there's not going to be a overlap or conflict in the future.
Right. So like, I guess the address assignment is the major part of this.
Of the rsub,
of the rsub, yeah.
So the use case we actually were faced with talking with customers back when we came to these things was, you know, you wanted to go autonomic, but then you do interconnect through a third party like a layer 3 VPN provider, and there you don't have the autonomic mechanism. So, but you wanted to foresee that the, you know, third party service provider at some point would also be able to integrate across it.
Sure. So I guess the other thing that comes to mind is that I think we say that you are not supposed to rely on the 40 bits of the address prefix actually being the hash of this stuff. And so who actually needs this if it's only being used for the hash? Is it just whatever's doing the IP address assignment?
So the idea is that the administrator types in his domain name, the UI runs the hash, okay, of that to make a ULA, which presents to him.
Yeah.
Okay. Which for most of people, they just hit next and it's done. They never need to know that again, unless they were to reconfigure the whole thing, in which case you get determinists the same thing. However, some of them realize, no, I'm supposed to use this ULA because, you know, there was some decision about previously installed whatever, in which case they overtype that ULA with something that they used last time, in which case they go forward that way. So at that point, yes, we generated the ULA from that string, and that's the default recommendation, but we don't want to ever have anyone else have to run that hash again in case they've decided that there's a different address space they're going to use. Does that
Right.
make sense?
So like we don't necessarily need to put that in the certificate directly. Maybe. I mean, you don't have to answer me right now.
Yeah,
That's just sort of a question I have.
There's a piece there that so that the at part is the ACP domain name, and that's just, like
that
a
you
realm.
need in the
That's just a
certificate.
realm,
Yeah.
right? And then we've used that to generate the address part, which we put the other part, and they're probably related, but we don't want anyone to depend upon it.
Right.
So that's why we put them both there.
So I guess my current thinking is my understanding is that we don't really need this RSub in the certificate, but we can think about it harder. Not
So
to
there
get
is
too much
always the
time.
fine line in terms of figuring out what is this, persistent type of policy that otherwise would be very hard to distribute, right? Because I mean, you look at something like Brewski, and if we're trying to have, core bootstrap information, that wouldn't be in the certificate, then we would have to reinvent kind of something as complex as this, as Brewski, and so that's the fine line. So we try to minimize it, and definitely the RSub is really at the edge of that information, right? And I think at this point in time, we just feel a lot more comfortable if we have it in there. But it's certainly something we also need to explore. We didn't have that in initial, pre-standard implementations, but basically there was a lot of interest expressed to be able to better address these larger deployment cases.
Definitely. Okay. Great. So I'm not totally confused about what this does. And then we've got this extensions part. So my big question, do we have any plans vague at all for what the extensions would be?
No, but the whole point, of course, is we don't want to end up in a way where somebody does introduce an extension and it's not backward compatible. So in the parser, we want to have an ability to be able to skip over things that basically can be added later.
Okay,
so
yeah.
just the extension points in the parser.
Right. I was just coming at it from like the X509 point of view, where having an extension point in the name of the thing being certified feels very strange. It's like a cognitive mismatch.
Sorry, come again?
So like in the certificate, this is going in the RFC 822 name field. So it's like the name of the thing being certified. And so having an extension point in the syntax for your name feels a little bit weird. I mean, I can sort of see how it might make sense.
Yeah, then there are these people coming in that want to have a PhD in their name, and you say, no, sorry, you can't have a PhD in your name. We didn't foresee that in the parser. That would be person name example, right?
And then, of course, we already sort of covered the ACP domain name. That's pretty key. It's the tenet of, are you part of the same domain or not? It goes into the authorization policy. It's pretty important. So I tried to make a little table, except table formatting in LaTeX is hard, so it's a list. And that's basically summarizing my understanding of what we talked about in the previous slides. So if I want to try and flip that around, okay, I've got these descriptions of the type of information that we need to know. How would I, greenfield deployment, try to map those into X509 vocabulary? So if we need to say something about the type of the thing we're certifying in the certificate, we can have X509 extension. That's a pretty common thing to have X509 extension to say, this is the certificate for doing thing X as opposed to the certificate for doing thing Y, as opposed to a web certificate or a CH certificate. And of course, we've got the IP address. We actually have a name type for the IP address. It fits very naturally in there. I don't want to exclude doing something else, but that's the natural mapping. The routing subdomain, I didn't have a great place to put because I didn't really have a sense for what exactly it was for. It might be skippable. We might have to find some place for it. Of course, if we're using X509 extensions, that's sort of an extension point. If we've not using the X509 name for getting the domain information in the certificate. And then the domain name, I didn't have as great of a natural place to put that. The best I could come up with was to say, okay, we've got X509 extension in the certificate that's going to be like our type marker for this is an ACP node certificate. Given that we already have that, we can stuff a little bit more information in there. The ACP domain name is kind of intrinsically tied to being an ACP certificate. So just from the sort of information model mapping, putting the ACP domain name in the X509 extension that's our type marker feels fairly natural. It's not a knock out of the park perfect fit, but that would be my sort of sense of how to do it.
Can I maybe give another point to think about it? So the primary, subject identification through the subject name kind of, to me, it always looks very similar to X400 identifying some object through this, type value list of pairs, right? And effectively, an RFC 822 address is very much the same thing. And actually, in the industry has won out over X400 to name objects, right? So the fact that we're primarily naming people or so is just because of the primary use cases, right? But in the way we're really just using the RFC 822 address field here for several reasons that are listed in the document, but it's very natural to use it to, describe, a person in the context of a naming authority, which is the domain, right? In the same way as we use it for people, right? That's why it's natural from that perspective. And the whole idea, of course, was not to use the subject name because we wanted to reuse these certificates. So somebody else might have already some assignment. The subject name needs to be something else. So we wanted to sneak in so that we can basically extend the use of existing, kind of that the certificates are used for something and the ACP.
Right. No, I sort of skipped over that part on one of the slides about the extension could be critical or not, because I know we're using these certificates for other things than just ACP communication. So we presumably would not have a critical extension in them because that would make it unusable for all those other things. And that was my last slide. So the other thing that I want to ask everybody here, Richard, go ahead.
What was the point of mapping it to X509 vocabulary?
Well, that's the idea in terms of if I just really can't get my head around thinking about this as an 822 name, what would the other options be for putting the ACP
the reason we
information
didn't do all these other things, and I argued for doing all this, okay, the reason we didn't go that way, or I was in the rough, as it were, was that we have operational experience that we can't get CAs to put anything in other than a name. And since they can verify the part on the right-hand side of the @ and that's a domain name, and they can verify the ownership of that, and they'll let us put anything that we like on the left-hand part, mostly, because it's not their business, that we at least could get through that part, right? And Torless also made sure that if they really wanted to verify this part by sending an email to it, that we could actually do that and create a mailbox to receive the email to validate the whole thing if we needed to do that, right? So that we just didn't want to fight the CA infrastructure because it's hard enough already.
This is like the CAB forum CA infrastructure, or
whether it's
related?
CAB forum or just the fact that the products out there that would implement CAs are set up for that kind of environment, right?
And that they are really reluctant to start certifying new X509 extension types.
But they just don't know how. You try to do it unless it's your own CA that you control enough detail on. You wind up with, well, you just can't do that here, right? So that's where it came from, and I think I've written the code. I think it's ugly dog's breakfast, right? But you know what? It doesn't done much. And we actually have on the client, on the new device, when we get the address, we have to parse it out because we have to get our IP address out of it, right? To configure things. So I'm like, can't I just have a 128-bit extension that just has my IP address in it, right? And the answer is, well, yeah, but how are we going to get it in, right? So easy in my code where I have a local CA, but I mean, you can't get, if as Owen is, since using Acme, literally let's encrypt for it. Right. It's just not going to happen, right? And that's the kind of space we just don't want that to be the blocking point for getting this deployed.
And I'm also looking from the operator's experience, right? So all the crazy tooling you may have, whether it's, OpenSSH or others, right? So, I mean, you always get the bloody RFC 822 address string in a human readable form. So, fortunately, there's a lot more non-autonomic administration on the security side, right? I mean, almost nothing there, you know, from the massa to the registrar. All these things are non-autonomic.
Right.
Humans need to surveil that, and so basically the 822 address is actually fairly easy to read for humans, right? And we don't have to define, let's say, standard presentations, which we otherwise would need if all the same information fields would be in a binary encoding format. I also have to define a standard human presentation, and then how do I get that standard human presentation to a lot of tooling that exists, right?
Right. That's sort of dovetailing naturally into the other question I sort of had, which is, you know, yes, I've heard that we need the human readable version of this, and you were just saying right now about how that comes in throughout several stages of the process, which is, you know, good for me to think about. And I just sort of final question about it is in terms of when we have the human readable part, do we need all of the information that's there, or do we just need the IP address? We need the domain name as well, the RSub. Is most of it?
I think the domain name. So, for example, if you're really saying, "Oh, I want to create different domains within my security context," right? You're a single organization. You want to have networks that shouldn't talk to each other, so their domain names need to be different.
Right.
So that's something that you would immediately have in any type of neighborship forming.
Yeah, you definitely
and then
need
the ACP domain stuff fails not because the keys are incompatible, but the domain name.
Yeah.
So the reason why, you know, you couldn't attach these devices would be immediately seeing, oh, the domain name strings are different, right? So all the pieces I think are important to see. Actually, the question of what would we likely see in extensions, I said we don't have an idea, but that's not true. I just didn't remember. So, for example, the one next logical thing is key roles, right? So we've been talking about, we have the role of the registrar, where we've been starting to put one existing flag in there already. Right, but there might be other important roles, like for the NOC to be able to push down policy into other devices. So things where we still are far away from complete mutual autonomic. Anybody can do something at the same level of authority, and those role things I think are going to be important extensions. That certain devices are going to be given certificates with a specific role. That would be an example.
Okay, excellent. Well, I know we're very short on time, so I don't want to take up more. Thank you for giving me a lot more insight into what actually the needs are here. And I will go back and ponder over it some more, and hopefully we can make some good progress. So thank you.
We still have 3 minutes, Michael, if you want to use that.
Can you go to the mic?
What about Brisky AE? Stefan Fries. I'm just asking because you opened the slide before, but then you did some reordering.
Oh, definitely, yeah. Give us your fastest speed.
Oh, gosh. Great. That goes back. So I would like to just give a short status update on the Brisky AE draft. So the draft basically originates from the fact that there are certain industrial scenarios where we can't apply Brisky as is, because there is limited functionality or limited connectivity to backend services like PKI services, or the PKI services like the RA or CA are more than one hop away. So the changes from the last meeting is basically some updates of the introduction text that relate to the usage of IDEF-ID and LDEF-ID. So it basically explains the self-contained object that is being used here or that is being argumented, and it explains that in a protocol agnostic way. I also updated the description of some architecture elements and changes in the Brisky architecture. So it's just an enhancement to section 5, which was already there. So the biggest change or the biggest enhancement of the draft is actually the introduction of an addressing scheme when more than one enrollment protocol is being used. So I have a slide to that one as well. And the consideration of existing enrollment protocols has been enhanced. So last time there was a discussion about that. We have currently EST with full CMC request included in the draft, and there is also a reference to CMP. Meanwhile, we are not referencing CMP directly. We're using CMP, the lightweight profile of CMP, which is currently being discussed in the LAMPS working group. So just to recall what is meant by authenticated self-contained objects. What we need for asynchronous enrollment is to have a binding of the proof of possession, which we get to the PKCS10 request, and then we need a binding of the proof of identity. That is being done in Brisky using the direct binding to TLS. If we have multiple TLS hops to the RA, or if we have a terminated connection and no connection to backend services, then we need something else. Brisky AE is basically motivating that with having a wrapped PKCS10, can be done with a CMS, for instance. So what we also need is a certificate waiting indication. That is what Elliot likes to reference as come back later for the soup. That has been included in the last iteration of the draft already. So I skipped that slide. So what I said at the beginning, we have more than one enrollment protocol. So unfortunately, we have that. So we have EST, CMP, CMC, SCAP. Within the ACE working group, there is a new EST wrapping being defined, which actually ends up in something like a self-contained object. So what we included here is a proposal for how to address the different enrollment schemes here. And we utilized what's already being defined in Brisky. So Brisky uses the well-known notation from RFC 5685. And we enhance that with what is shown here on the slide with enrollment protocol and request. And enrollment protocol can be exchanged with EST, which is natively used in Brisky, but it could also be some of the other protocols that are stated there. And the request would basically be something like simple enroll that is being used in Brisky, or full CMC request, which would be used in Brisky AE for the self-contained object. So open issues that we see, Brisky itself, so regarding the naming scheme or the addressing scheme, Brisky uses EST over HTTPS. If we also take into account what's happening in the ACE working group with co-op EST, we may enhance the naming scheme to also support co-op S instead of HTTPS there. So what's being necessary is a selection of a set of mandatory enrollment protocols to increase interoperability, but keeping the option to also select other enrollment protocols. That brought us to the introduction, at least partly introduction, of some kind of discovery mechanism, which is optional. That discovery mechanism could use the naming scheme for the different enrollment protocols. So a pledge could easily be discover which enrollment protocols are supported by the registrar. So next steps, further refinement of the approach. Then we have some discussion between the authors regarding the operational modes. So right now, Brisky and Brisky AE are both targeting some kind of, I call it pull behavior. So the pledge is always acting as a client, but there are certain scenarios where the pledge is also acting as a server, which what I refer to as push scenario. And we are currently discussing about how to integrate this push behavior into the draft by keeping all the different architecture elements which are already there in Brisky. So to not change too much of the architecture, but being able to let the pledge work as a server. And well, that is actually the reason that I think right now it's not the right time to ask for adoption. We have asked for adoption last time, but then this new feature came into the picture, and we thought it's better to not ask for adoption. So it's just an update that I would like to give you.
When you're saying the push stuff, would it still be, a separate small, HTTPS, like a separate one, which, I mean, Brisky right now is kind of EST++, so
yeah,
still limited context, or even in a more broader context, like let's say in a netconf REST connection, which may be even broader.
It could probably also be a broader approach. Yeah.
Have you talked about any of that push stuff in the context of netconf?
Not
Because
yet.
I mean, they obviously have some opinions of their own in terms of already having a bunch of components like certificate enrollment that would replace 7030, but obviously nothing that would replace the Brisky elements, right? So that seems like a fairly big difference in how they do encoding models or so, but maybe the Brisky steps would be logical to bring into that context as well.
Right. So what we had in mind here are two different modes actually for push. One is just push the pledge to start with Brisky. That could be if the network is discovering that there is a new device in the network instead of the device is discovering that it's happened to be in a new network. And the other thing would be to reverse the roles that the pledge is really the server.
Okay, that finish our all presentations. We're already 3 minutes over time. No? Oh,
It's 2:50.
oh, 250. My fault. Then
Sorry. Just who has read the document? The latest one. This was AA. Okay, 1, 2. All right.
okay, so Michael. Yeah.
You can do it.
Sure. Hello. My clock is 5.
But you need 2 minutes to wrap up. Just talk. So I started a document which I did not post for a variety of personal emergency reasons, and call it delegated voucher. We use vouchers in a bunch of different places, and what's the next slide here? And it has some problems, okay? It must be online, it doesn't support second sale, manufacturer goes to business, you might have to throw out the device. And SZTP, which is the NetConf version, works better for a number of online uses, but it still has almost the same difficulties. If the guy goes offline or whatever, unavailable, then your things don't work and you can't resell it necessarily. So the problem I'm trying to solve is second sell from a willing seller. So someone who actually could do something perhaps before they put take the device off their network and put it in a box and ship it to you. Second sell via creditor, bankruptcy, etc., which means that the enterprise that has the equipment essentially is non-functional, doesn't exist, and you can't really get anywhere with it. So that's a second problem. Manufacturer of assembly or composite devices. The example has been given as a passenger rail car that might have a whole bunch of interesting sensors on them, which will be not proxied. So they'll actually all be on the network and they all need to be onboarded. But the assembly needs to be onboarded together, and they don't want the devices that you assemble with to each be having vouchers from their manufacturers. You want some other process, and the same situation's been said for factory kind of environments. Disconnected owner, that's the classic, or we've had the military base example with light bulbs. And the example, both Owen and I thought Stefan wanted to be able to pin a cloud PKI registrar and have things change. So that was kind of what I was trying to solve. Basic shape of what I'm proposing is that you have some kind of array of serial numbers which you are going to write a voucher for, and that you pin an intermediary who can then issue another certificate which is more specific. And then you might have a limit to how many of these chains of certificates that you could have. Okay, that's the general shape of what it would look like. So imagine this is the first case. You had a delegated voucher, this DV1, to owner number one. Owner number one effectively can now run a MASA and can delegate to owner number two. Okay, and the pledge has to evaluate the whole set. So you have to send the DV1 voucher along with the ephemeral voucher so that the pledge can see, I can go from the original MASA to the first owner and then to the second owner, right? So you have this chain of red thing. And here's another example with a third thing. How many layers in this chain do you want to have? Well, that's an interesting question, whether you want to have a limit or not. One of the things that you can do with this is owner one could be the same guy as owner two, but owner two is when he has a new CA, right? So the last thing he does before he gets changes from GoDaddy to Thoughty, right, is issue himself a delegated voucher for his new name, right, which lets him basically continue operating. That's really it. Okay. And in intermediary, I have conversations with some companies that do, essentially they collect equipment from bankrupt companies and resell them. I met these companies because they're good places to buy really good equipment from, rock bottom prices, right? The issue is that, well, they don't have anything, right? What are they going to do? How am I going to get ownership of things? And so they may be able to negotiate with the manufacturers better than I can. And in particular, if they do it right, then they may be able to essentially go in and put their own trust anchors into the equipment and have the expertise to do that, whereas I either won't or I won't have the right chance to do that. So they could resell things and do that. And there's a bunch of cases where people have said an intermediary would help add a layer of indirection. It's always the solution in computer science, right? That's it.
Thank you, Mike. We don't have time for any discussing, and that's the end of this anima session. Thanks to you all, and hopefully see you in Vancouver next match. Right? Thank you.
Yes.
Brian, when you have a minute, just. Understand, and I think for me the questions are related to reading all that stuff and understanding use cases, and I'm just wondering, depending on the use case, whether it makes sense to further extend, okay, we have one of the we have those as opposed to trying to figure out use case whether it's better to improve the boost functionality.
Did you ask a question regarding to the wiki? Yeah,
and
are we going to have a wiki page for the UIP site meeting or what?
Then you're allowed to work that stuff. The question really is, what is the use case? Why do you use those models? Is then for those use cases extending and that's the best. So I think that's a higher level use case workflow.
Okay. So
if you are saying that there isn't another already existing other,
but that's potentially that's the purpose. The split page setup.
Yeah, so if there is no better culture than that boost functionality in, then you want a new kind of transport.
Yes, right.
That's kind of. I mean, to me, boost is a amount of it, right? The
Yes.
boost you can put it, they're pushing it out, and the other one is boost as a particular transport, and if you like some HTTP. Right, and I want to separate between those and always also for proliferating the EST
Maybe
that makes sense.
Yeah, I already asked Brian the question. That's the meeting wiki, and he doesn't think that's the right way to use it. Also, we could use it because nobody really uses that in that way.
The meeting wiki, I think, is just announce the meeting, right? Everybody is then pointing to their